Hello out there, my Phoenicians. Welcome to Lesson 6.4, Part 1. Pretty quick notes today, but we are going to cover a new concept known as factorial notation. Factorial, what it does, it's kind of shorthand for us mathematicians, and what it looks like is some number, so n is a number, and then we just put an exclamation point after it. Seriously, that's what it is. That's what we refer to as a factorial. Now what that means is, and this is for really any number greater than or equal to 0, so integers greater than or equal to 0. What that means to do, so for example, if we had 9 factorial, that is like taking 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Not times 0, we stop at 1. Okay, so n factorial is formally n times n minus 1 times n minus 2 times that number minus 3, and so forth, all the way down to 1. Okay. This will come into play. We'll talk about some word problems in a bit when you use this process. So 9 factorial, 9, 8, 7, 6, 5. Something like 3 factorial, pretty self-explanatory, hopefully. 3 times 2 times 1. 1 factorial, just 1. And here's a little trick. 0 factorial is 1. What? Okay, 0 factorial, you would think it would be 0, but the key thing is it is 1. So 0 factorial is 1. There's proofs for this online and so forth. I'm not going to bore you too much with that right now, but go ahead, you can look up why is 0 factorial 1? Why is this the case? And there are some interesting videos on YouTube to watch for that. So just remember, 0 factorial is 1. For all other cases, integers, we are considering subtracting 1 from that original number. Also, you won't have to worry about negatives in this case. We're going to keep everything positive. So for example, to evaluate 5 factorial, that would be taking 5 times 4 times 3 times 2 times 1. Okay, 5 times 4 times 3 times 2 times 1 is 120. So 5 factorial is 120. 12 factorial, okay? This one here. Now here's a little shorthand on your calculator, so watch. If you want to use your calculator and you don't want to type in 12 times, so that's what it is, 12 times 11 times 10 times 9, so forth. Okay, shorthand on your calculator is if you type in 12 and then we do math over to probability and hit 4 or the exclamation point, that will find the factorial for you. So 12 factorial gets pretty big pretty quick. 479001600. So factorials get pretty large pretty quickly. Okay, and we're going to cover how to simplify some of the larger ones in a few minutes here. 3. So 3 factorial times 4 factorial. No, it's not just 12 factorial. We'll see that here. 3 factorial. So 3 times 2 times 1 essentially is 6 times 4 factorial. 4 times 3 times 2 times 1 is 24. 6 times 24. And again, you could have used the shortcut method, is 144. But notice it's not the same as 12 factorial. Okay? The multiplication between, you want to do the factorials first, okay, and then multiply together. 70 factorial. I am not going to write down all 70 of those, but I just want to show you, if you try that in your calculator, PRB 4. Okay, you're going to get overflow. Okay, that's just because the number is massive. That's okay, but the next problems I'll show you how we can fix that for the most part. Okay, so it's just a huge number. I think 69 factorial. Everyone's like, 69. I think that is the last one, actually, your calculator will do. It's convenient, huh? Okay, so that's a huge, huge number. Anyway, simplifying factorials with like division. It seems scary, oh my, but really it's not bad. So let's just think about this. If we were to write it out, number 5 here, this would be 5 times 4 times 3 times 2 times 1. The denominator would be 3 times 2 times 1. So, without even really multiplying all that in my head, noticing that the numerator has a 3 and the denominator has a 3 and a 2 and a 2 and a 1 and a 1, really, all I'm doing is 5 times 4, which is 20. You could check that, certainly, in your calculator. I would put parentheses around the factorials to do that. So, just as proof, math 4 divided by 3, math 4, boop, 20. There it is. That's exceptionally helpful for something like number 6 here. We already determined 70 factorials unsolvable, or too big. Not unsolvable, just overflow. So really, this is the same as 70 times 69 times 68 factorial. Now, 68 factorial, I would just be writing all those numbers down, which I would also be doing in the denominator here. So I'm just going to cancel them out right here. 68 factorial, 68 factorial, because really, that's what I would be doing if I wrote them all out. So honestly, I'm just worried about 70 times 69, which is not an overflow. And you get 4,830. So you can cancel out large chunks of factorials. Just write it down to the particular denominator or numerator that you have. Alrighty. A little bit different with 7. This actually turns out to be our formula we're going to deal with in the future. It's the NPR, or permutations formula. But anyway, 5 factorial over 2 factorial times the quantity 5 minus 2. I recommend just kind of simplifying it as you go. 5 factorial over 2 factorial, and then this would be 3 factorial. Okay, you can type it in your calculator at any point. You can also notice this would be 5 times 4 times 3 factorial all over 2 times 3. Something that happens is, so the 3 factorials can cancel. It will still leave this 2 factorial down below, okay? We'll still have to worry about that, so only one instance cancels. So it's 20 divided by really 2 times 1, which is 20 divided by 2 is 10. Again, really at any point, you could type this into your calculator. You could do the whole thing if you put extra parentheses around the bottom. But try and get the hang and recognize what's going on with writing out the factorials. Number 8. So notice 10, 9, and 8, there are no factorials. There's no exclamation points. But the denominator has one. So just think of it as 10 times 9 times 8 divided by 10 factorial would be 10 times 9 times 8 times 7 factorial. We would have all those other numbers. You can cancel these out. Boop, 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 boop. That's going to leave, though, a 1 in the numerator. You need that placeholder. And then 7 factorial in the denominator. 7 math 4 is 5040. Again, another problem you could probably do in your calculator, but you should get the hang of recognizing the redundancies and canceling those out. Okay. Last two problems, just recognizing these in terms of our word problems. Really, we've done this similarly when we counted in the previous lesson. Standing in line and ordering without repetition is really using factorials. So 8 friends are at Hershey Park in line for the Great Bear. How many ways can they stand in line? So if you're thinking there's 8 ways the first person could be in line, well, as that first person's in there, there are 7 ways the next person could be in line, and then 6, and then 5, and then 4, and then 3, and 2, and 1, which is the same as 8 factorial, which is 8 factorial 40320. So it doesn't seem like there would be all that many ways, but you and just 8 friends at Hershey Park, 40,000 ways you can stand in line. For number 10, 6 racers, 100-meter dash. How many ways can all 6 finish the race? So first place, so once they start the race, there are 6 people that can finish in first. Well, once that first place finisher goes, there's 5, and then 4, and then 3, and then 2, and then 1, or 6 factorial, and that is 720. Okay, so key thing, factorials, they can be used if you're using up everything and without repetition. Okay, the same person can't finish twice. Factorials, just break up things if you can. 0 factorial is 1. All right, and that's really the main idea of this first part. So great job, try out the practice, and good stuff.